Let's get ourselves together so I can introduce wonderful Mr. Tapasvi Bhargava.
Good afternoon, everyone.
Mr. Bhargava was born and raised in Haryana, and he was coming from an agricultural heartland surrounding Delhi. His journey began far from the biomass sector, which is the majority of what our today's presentation is about. He has a family business rooted in steel that initially followed a similar path, but when COVID-19 came around, there was a pivotal shift, and that shift is the focus of today's presentation that I hope you all will enjoy greatly. Thank you so much. Let's give a warm welcome to Mr. Bhargava.
Thank you. Thank you, Daniel. So yeah, I'm really not an expert presenter and this and that, so bear with me. But yeah, this is something interesting and which I'm going to talk about for next few minutes. I'll just give you a brief presentation on what I am now involved with so that you have a clear idea, and then of course we can have questions and answers. So quickly, there's a thing called biomass supply chain management and biomass pellets and briquettes. This is what our company is doing, biomass supply chain management. I'll give you a brief summary. There are lesser slides, snapshot of the problem, the business model, advantages, of course, company profile, geographical locations, products and services, some videos for you guys to get an idea of how it's being done, and the impact it's making, whether it is social, economic, or environmental impact. Now, okay. The problem is when the farmers, they harvest their crops during the harvesting season. After harvesting the crop, whatever is left over on the farmland, they want to clear the land, and how they clear the land traditionally is that they put some gas or kerosene and they burn the rest of the biomass which is left on the land. So process of burning farm residue, mainly parali, we call parali, which is paddy straw. There's a lot of paddy straw around Delhi, like all the neighboring states which are which have agriculture background, they have a lot of paddy straw. Is one of the major causes of air pollution in various parts of India. Stubble burning emits toxic pollutants in the atmosphere like carbon dioxide, methane, and VOC gases, and eventually affect air quality and people's health. Soil becomes, now the second part is, soil becomes less fertile and its nutrients are destroyed when the stubble is burnt on the ground. Stubble burning generates heat that penetrates in the soil, causing an increase in the erosion, loss of useful microbes, and moisture. So you are destroying the fertility of the soil, also you're polluting the air. So it is that serious. Now the business model. Now this is the problem, and the business model which we have now come up with is the group has emerged as a contributor in biomass supply chain management by building vast sustainable networks with farmers and professionally managing biomass stockyards across various states in India. Their biomass is supplied for production of 2G ethanol, whatever we collect, the biomass. We tell farmers not to burn biomass, rather we collect it and leave their land as it is, right? So the collected biomass is supplied for manufacturing of 2G ethanol or to produce compressed biogas. Further, the biomass which are having higher calorific value, all of you understand calorific value, right? The energy in it, the heat energy in it. Having high calorific value is converted into pellets and briquettes to replace fossil fuels such as coal, which is burnt in the boilers across various industries. So we are also replacing burning of fossil fuels, that is coal, by a carbon neutral fuel, which is biomass pellets. Now, advantages and target sectors. Now, advantages of this business and solving a problem. Affordable and carbon neutral energy for India's fast increasing industrial production. They are getting carbon neutral energy, which is emitting net zero emissions of methane or carbon dioxide. And it is affordable. more reliant than getting and burning coal, right? Monetarily enabling every stakeholder involved in the supply chain, including marginal rural farmers, farm laborers, farm equipment owners, and having enormous impact on air quality index. Now, this is the advantage of this business model. Of course, target sectors are compressed biogas, food and dairy process industries, textiles, cement, tire, pharma, chemicals. All these industries, they use either biomass pellets or they utilize compressed biogas in one or the other form. Impact. Now, this is the direct impact what our business is making so far, which is just for you guys to understand. Over 500,000 acres of farmland are preserved from each season from being burned. Approximately 80,000 farmers have experienced financial benefits alongside numerous other job opportunities in rural areas. As I said, you need laborers, you need farm equipment owners, you need drivers. So all of that, the rural population which was not getting any employment opportunity and this and that, they all get involved in this. So apart from 80,000 farmers, there are other job opportunities also. Annually, there has been reduction of 750,000 metric tons of carbon dioxide emissions. 1 acre of land saved from burning biomass saves you 1.5 tons of carbon dioxide emissions getting in the air. This initiative has been operational for 3 years. For our company, we have increased the impact by over 200% compared to last year what we did. Because the bioenergy business is new and it's turning around fast in India. It's more acceptable now. This is about a little bit of my background also. Quality Group, that is the name of the company which I'm director in, is a multi-locational, multi-product organization having its manufacturing base in stainless steel coils, pipes, so like typical steel industry. And then bioenergy, it started after COVID, as Daniel explained. Group has forayed its presence in bioenergy, being a leading indigenous contributor in biomass supply chain management and producer of biomass pellets. With its vast network of biomass aggregation and professional yard management. So there are two things, aggregation of biomass and also managing the yards where you are collecting the biomass. Because it's also very dangerous. You know, it can catch fire, it can easily be burned down. So professionally managing the yards, the group has track record as dependable and committed supplier to marquee corporate customers. So we have customers which are bigger corporates who are in turn making 2G ethanol, who are in turn making compressed biogas. These are Fortune 500 companies. Yeah. Bioenergy manufacturing business derives its strengths from organized supply chain management of biomass. That is very important to understand the supply chain management. State-of-the-art quality testing, of course, and production facility with committed supplies. So committed supplies was the key when we started this business to understand what was the issue. Of course, at Quality Group, we are committed to the UN Sustainable Development Goals and adding positive impact on the environment and communities. These are the locations. So you see this small dot, this is Delhi. And this is all over around Delhi where the stubble burning happens. Haryana, Uttar Pradesh, Madhya Pradesh. So all this part of India, there is rice. So stubble is what? Rice. And when you harvest rice, whatever is left over, people used to burn that. Now that's not happening in most part of it. Products and services. So what we do is biomass aggregation and yard management across Haryana, UP and Madhya Pradesh. Shredding of biomass as per requirement. So you collect the biomass, you shred it, and logistics to the customer sites. So these are a few important things which are required, logistics also. Then manufacturing of biomass pellets. This is the calorific value I was talking about, around 3,400 kilocals per kg and above. What you have to take care of is moisture, ash, so these are quality standards what you have to maintain. A small video just for you guys to get an idea of aggregation. This is aggregation of biomass. Can we have sound in this video? Just in this video. So this is paddy, rice.
We're not just a company. We are a solution to challenges
That's
like
the song is not.
burning and water stagnation.
Okay, I think. I don't know. Is it? All right, I'll explain it to you guys. So you saw the biomass that was being collected. Now these are the yards. This is how we store so much of biomass. And of course, there has to be, this is how the logistics works. That's how you collect it from the farms. Then you weigh it at different locations. And then it goes to the yard. These are some mobile testing equipment like moisture, ash, which your end customer is always concerned about for their product quality. So that's how a yard is located within the farm reach. You have to be very careful how much biomass is stored in each yard. Okay. It's just in case of fire, you need some water storage around the biomass. Each yard also works on solar energy, so we try to avoid using any other energy. Since we don't have a sound, so I don't know what is being explained. But so you guys must be finding things repetitive, but yeah, this is all biomass, basically, which was being burnt. So there's one of our yards. That's how you collect it. None. There's another video which will show manufacturing of these pellets from the biomass. This one. So this is how you collect higher calorific. Yeah. We don't need volume, it's just the music. We don't need volume here. Yeah, that's fine. So this is a pellet manufacturing plant. Pellet manufacturing, there's a lab where you test when you collect the biomass. So you see it's very rural setup. That's how it's supposed to be, but a safe setup. All the women, the men, these are all local women and men from nearby villages who get opportunity to work. And these are the biomass pellets which are replacing coal. They get burned, they replace coal, and this is a carbon neutral energy. So all the industries who are aware of making environmental impact, who already have ESG programs, they prefer buying biomass pellets instead of fossil coals. So you feed in biomass like that, it goes through the hammer mill, it crushes, the sand comes out. It's all very local equipment, local ecosystem, and yeah, that's how it's packed, and then it goes to, this is again a biomass. Then it goes to power plants, it goes to all other industries who are using coals. Government of India has a policy. Now, the impact, this is the last slide of the presentation. Impact. So there are three kinds of impact we are making with this. Social impact, by monetarily enabling every stakeholder involved in the supply chain, including marginal rural farmers, farm labor, farm equipment owners, vehicle drivers, and indirect beneficiaries. Now, all of these were actually jobless. Most of the India is like that, not jobless, but it's an agrarian economy, India. And if we are monetarily enabling all these stakeholders, everyone gets interested in this bioenergy business. Environmental impact, more than 500,000 acres of harvested land is being saved every season from burning of biomass post-harvesting. This has enormous impact on the air quality index. Economic impact, affordable and carbon neutral energy being utilized by corporations. So this is an economic impact for corporations who are buying this biomass, who are buying the biomass pellets. This is a thank you slide. One last slide. This is being sent by my daughter. I had to put it up. She just called me. Let's change the world with kindness. Okay. Thank you.
Woo-hoo.
Sorry for the little longer presentation, but yeah, now I'm a little more comfortable answering your
You
question.
want to take a seat? No, I think it's not a long presentation at all. It's also rare with the morning program speakers we get to have someone go so in depth to the exact like unit specifications for their product and the actual logistics sort of timeline. So I enjoyed it a lot. I wanted to just ask for our scholars here how you got into this business. So what changed from sort of a family steel background into biomass, into pellet making? How did that happen?
Yeah, I mean, if I have to think about that, it's actually health issues around the community. What you could actually start seeing visibly. You could see small children, you could see elderly, you could see a lot of them having breathing issues, having lung issues, coughing all the time. The spark came from there that, you got to do something. You get frustrated by just seeing these health issues, like in your family also and people around it. So that was the spark. So
That was the spark.
yeah.
Okay.
Yeah, one of us from the community only has to do it. Has to come forward and take charge of it. So,
Who was the first person you asked for help or told about the idea for this business that helped you make that happen?
so things were happening at the same time. Things were happening. In 2014, the new government came in. In 2015, India signed Paris Accord, which they made some commitments for the world by 2030, India will emit that many less carbon dioxide, that much cuts in the emissions, and they will start using non-fossil energy.
Yeah.
So everything was happening. So I'm not the only one who came around with the solution, but yes, it was the government's push. And that's how bigger corporations, they focus their investments into new energy that is either green or carbon neutral.
Mm-hmm.
Carbon neutral is compressed biogas or 2G ethanol plants, and which sort of opened up a window to explore more solutions, because money started coming in. Then someone started coming up with the technology to make compressed biogas from biomass. So that was also an Indian company. Here I was exploring the idea of aggregation. So, I was part of the solution, but not literally I did not find the solution. So that's how it happened. So someone came up with the technology, bigger corporations invested, believed in the technology, government made the push they subsidized the end users, they subsidized the farmers, and that's where I also got in. So,
There you go.
yeah.
Jumping back to one of your slides that you mentioned previously, on average, you save 1.5 tons of CO2 emissions per acre.
That's a theoretical
Theoretical
gauge.
amount?
That's how they've gauged.
Understood. And
Yeah.
you have 500,000 acres. It's about 750,000 tons of CO2.
Yeah.
Is that per year?
Per harvesting season.
Per harvest, which is
Yeah,
once
per
a year.
Per year. Also, you know what happens, other than paddy straw, we also, so then people sow in mustard, people sow in millets, people sow in wheat. So we harvest, so we collect biomass then also. So per year, we sort of do twice, but not the same acreage, little less, but it could be more than 500,000 acres because there are 2 crops on every acre every year. That's the average of India.
To give some context for what 1.5 tons of CO2 is, it's your average gasoline car driving for 8,000 kilometers. So that's about what is saved per acre, is an 8,000 kilometer car journey. I would love to talk about sort of the end process for this cycle with the textile and sort of manufacturing plants with boilers that are switching from coal to the pellets that you provide. On average, the kilogram per kilogram calorific amount for your pellets you mentioned was 3,500.
You can also call them joules.
Yes, megajoules. Yeah, it's about
just
14 megajoules if you do the conversion. So that 14 megajoules.
That's a unit of energy.
Yeah.
Yeah.
Coal is about it's about 7,000 versus the pellets 3,500. So what incentivizes, besides sort of an obvious moral incentive, what's the process for those companies with boilers deciding to switch over to pellets?
Yeah, so you get all sorts of coal. So some coal has a higher calorific value, some coal has a lower calorific value. Like in India, you get most of the coal from Indonesia, which the calorific value is around 4,000.
Yes, much lower.
And when I say 3,400, it averages above 3,400. That's the minimum. So that sort of averages out the coal consumption. Also, there is a lot of ash when you burn the coal. And to dispose of ash, it is an issue. I mean, where do you dispose ash? In biomass, ash is less than 20%, less than 15%, the kind of biomass you're supplying. Coal has ash of about 30 to 40%. So these are things, and industries don't want to deal with like ash also.
Absolutely.
Moisture, coal has more moisture, biomass has lesser moisture. So there are, it equates to the benefits the corporations must be getting from using coal. It equates with that. Plus it's carbon neutral.
Absolutely.
They get carbon credits, which is money.
Yes.
So
you mentioned that you've had an increase in 200% of your operations just in the last year. How did that happen?
How did that happen? So there are few things. I mean, technology which was made in India to produce compressed biogas. Technology which was made in India to produce 2G ethanol. People were not relying on that technology much, and everyone was concerned, but that technology worked. Biomass aggregation, people were concerned that how will that happen? It worked over the last 2 years. So people then got confident, the end user got confident, and then wherever they had a capex of, let's say, X amount, they have increased the capex to cover the entire country now because they have a good confidence on biomass aggregation. They have good confidence on technology, which is converting their fuel into a gas, into a power. So turnaround is from all these things, and then governments push that, okay, they are still giving out subsidies, they are still promoting usage of biofuels. So all of that, I think, there's no one reason.
There's no one reason, just expanded.
Yeah. And also, I mean, I've been doing steel business for last 16, 17 years. Steel is hardcore, There are bigger corporations who are supplying you raw material. There are bigger corporations who are doing logistics. There are bigger corporations who you are selling to. It's all fixed. Over here, you are dealing with very small people and you're buying material for them. Their house is running from that sale. It's an extra income for them. You are using very small transporters, small equipment owners. You're using unemployed laborers who were not employed earlier because these people are from rural India. So all this emotions also, it is different, and it's you enjoy all of that. So it's much more appeasing for anyone compared to working in any other sector. Yeah.
Absolutely.
Yeah.
What is a policy that you're most looking forward to possibly coming into fruition in terms of like a government policy that could happen?
So government, as I said, government is focused, but so far the government's focus was mostly on farmers and the end users. The government had given subsidies promoting farmers to not to burn biomass. They would fine them and things like that, and they would give subsidies to end users who were using the biomass. Now what we are looking at, the key player in this, or the kingmaker in the entire supply chain, is an aggregator.
Which is you.
Which is us or other companies also. But everyone realizes aggregation is the toughest part. Whoever can do aggregation has sort of now made their name that, okay, you can aggregate, now you are the key part of the supply chain. Now there is no policy from government on aggregation. What policies are required? Subsidies on transportation, logistics equipment to the rural entrepreneurs. Subsidies on insurance to the rural entrepreneurs on buying these equipments. Subsidies on warehousing for aggregators to store these. So these things are not there. And I think if these things come in, automatically this X will expand to 1000X. Then we don't need to go and convince each and every stakeholder that this is the problem and this is the impact of the solution, and how you will be benefited. So us versus government, there's a big difference. If government's reach is a big, so I think that is what now we are looking forward to if this thing comes in.
You said that the aggregator is the kingmaker, and it's sort of, you make a name for yourself if you're able to do it because it's so difficult. I was wondering what sort of makes it so difficult. I have maybe a hint that you gave me. The average farm size in northern India is 5 acres per farm,
which
and
is
so
very small.
If you're working with 500,000 acres, you're talking to 100,000 different, basically customers that you're the purchaser. So you're having to purchase from 100,000 different suppliers. Most businesses struggle with having 1 or 2 suppliers that don't get to them on time. So is it just some gigantic, ungodly 100,000 long list spreadsheet that you're working with, or how does that work? How do you talk to 100,000 people?
So you have, let's say if there's a compressed biogas plant. Each compressed biogas plant needs a biomass that covers around 25,000 to 30,000 acres per year. So for that, you need 2 yards. So yes, these 2 yards will maintain a spreadsheet of literally those many people. And that's where, you need ERP systems. You need things to figure out who's the farmer here and what is he sowing. And also government has data. So but you have to localize it. You cannot decentralize it. What happens, a lot of bigger corporations, a lot of investments came from different venture funds into India, and a lot of them didn't do well. I mean, why we could survive so far is that we localized it. We did not decentralize. We did not centralize it. You have to decentralize it. You have to give it to the yards. Each yard will get local ecosystem into working. So you'll have local yard managers. Local people would be supplying biomass to you. They will have contacts with local farmers. So it automatically works very fast.
Do you own those farms, or those yards, or are the yards their own sort of entity separately within this long supply chain?
Sorry, come again?
Absolutely. The company that you sort of run, are the yards that are supplied the biomass, are they part of your overall corporate assets, or are they another vendor that you work with?
So our company is Quality.
Yeah.
And the farmers are our suppliers, vendors. They supply to Quality.
Directly to quality. Okay.
Directly to quality, or sometimes they supply to smaller stockists, and those stockists also supply to us. So in between there are balers, people who own baling equipment to bale the biomass. So they also say that, okay, we will supply you 1,000 tons of these from this much, so we don't touch those farmers, and then they directly supply to us. So there are small balers also involved, small stockists also involved, because you have to respect the ongoing ecosystem in the village, in the rural India. You have to respect that. If you don't do that, then it becomes difficult. It takes time. You can't turn around the volumes like that.
I'd love to talk a little bit about the difficulties or the strategy around storing the biomass. Since there's one harvest per year, you then have to sort of spread out the pelleting and the burning of those pellets in a sort of linear sense over the course of an entire year. And it's very similar to problems faced in wind and solar energy, where, for all the students here, solar it's very, very steady in what you can expect. It goes up during the day and goes down at night in terms of energy provided. Yeah. Whereas the consumption of energy from households goes up in the morning, down during the middle of the day, and up at night. So solar hits right at that trough where you don't want it. Wind is less predictable, but usually there's less wind at night. So there's these ups and downs along curves that are predictable and unpredictable in energy consumption. And here with biomass, we have a totally new curve, a new thing to deal with, which is you have one harvest for the whole year, and you have to make it last at a nice steady state the whole year. Yeah. How do you make that happen?
Yeah, so earlier what used to happen is before people used to have these warehousing yards, people used to tell farmers to just stock them in their farms, and we will just pick it up as and when required, right? And it used to get burned because it's very dry. So it can burn, like if there's a lot of heat during the day. It's
almost explosive.
Or if there's some electric failure and things like that. So, and then you compensate. Like we saw this, and we went to farmers. Then we decided, okay, we will need to have yards which are actually audited and assessed by safety agencies, that how much biomass we can keep, what equipments we need in case of any emergency. So all that, we have standard operating procedures to store it. Like there has to be, because it's very inflammable.
Absolutely. I remember watching, if anyone has seen Mythbusters here, there was an episode like 10 years ago where they took sawdust, which has a calorie energy of about 8,000, and they used it as a literal fireball cannon. So I can imagine all the safety that needs to go into storing this properly.
Yeah, so you have to have audited yards from these safety agencies, and train your manpower to that. Like you cannot store more than 10,000 metric tons in more than 14 acres. So that's the limit of the yard. Then you change the yard. So nice. This is just to avoid any such thing. And also you insure whatever you store. There's insurance we buy.
What's the next step for you, for your company? What's that next investment?
I'm not that visionary, but next step is, of course, so we are collecting biomass, we are supplying biomass. Another revenue stream is making pellets. Another revenue stream is making compressed biogas. So we are looking at doing joint ventures with publicly held companies, Government of India, to set up compressed biogas plants. Also, we are exploring other states within India to set up more pellet plants, to create more to collect more biomass, and also outside India, Brazil. We are exploring some partnerships there. Also, we are looking at export of these pellets. A lot of these pellets are exported from other countries.
Why specifically Brazil?
Brazil has the largest biomass bank available in the world, because they grow a lot of sugarcane. They are the largest producer of sugar. So the sugar leaf trash has a very high calorific value. It has around 4,500 joules. So that's the best fuel you can get. So that's why Brazil has a lot of, and the key is to have biomass. Then you can make products out of it and sell.
My final question before we get to the Q&A, stream that we haven't talked about is just pure compost to sell back for agricultural purposes to help, strengthen the soil quality. Is that a stream you're considering, or does the sort of the monoculture of the biomass you're collecting make that impossible? Does that make sense? Like, I guess what I'm really asking is it possible to create just pure compost that you can sell back to farmers from their own biomass waste, or why not?
Like sell back what to farmers? Like.
I think a question that a lot of people, when they're first introduced into biomass in their heads, is they think, oh, I have my auntie or my uncle that has a nice little garbage can in their backyard with worms and dirt, and they make their own compost, and they reuse it that next season to make their garden stronger.
Okay.
What is the difference between that and what you do in terms of collecting that biomass?
So difference between that is, the scale, first of all, the scale, because the destruction, what is happening, the scale of destruction, what is happening with burning of this biomass versus what you are saying is very, very different. Over here, people's health are at stake. And when I say people, like millions and millions of people, because by burning as I said, 1.5 tons of carbon dioxide is emitted by 1 acre. And you are talking about millions of acres. Things are happening. So the difference is you take it away from those people. You take the responsibility away from those people that they don't have to worry about it. The best part is they are carefree. Okay, you are taking it away. You do whatever you want. So they don't want to, it's hassle-free for them. So that's the biggest part. So they don't have to, store it, do this and that. You are taking it away, processing it, selling it to someone else. And that's why you are also in, so that monetarily also it is beneficial to you. Yeah.
Nice. All right. I think let's open up to questions from the scholars. If we can pass out some microphones. Who's got their hand up first? Yes. Perfect.
Easy. Be easy.
Be easy.
Hello. Thank
Hi.
you so much for coming today to speak with us. I had a quick question about...
What's your name and where are you from?
Oh, I'm Juliana. I'm from Poland, I guess. My question was, so moving forward, let's say in 50 years, what would you say the projected market share of biomass in the future energy mix would be, if that makes sense?
Yeah.
And whether biomass right now is sort of a band-aid transitional solution, or do you think it will be a staple energy source
Good
of
question.
the future?
I mean, it's a good question. And I can talk about India because that's the figure I know. Government of India actually has a number, and they want to ensure that by 2035, India should be utilizing 35 to 40% of its energy from non-fossil. So in that there is solar also, there is wind also, and there is biomass also, right? So of course solar is higher in all of this. If the number is 40%, solar is about 20%, right? So wind and biomass might take over wind because the amount of biomass available in India. So I think approximately 15% of India's energy requirements will be catered through biomass. Right now, government has made mandatory for all the power plants in the country to utilize 5% of their coal requirements from biomass pellets, to replace 5% of their coal requirements from biomass pellets. That's a policy from the government. So you make pellets and you supply to power plants. But we are not able to fulfill that. We are not able to aggregate that much biomass. We are not able to process that much biomass because it's still evolving. It's a new field for at least India. So yeah, 40% non-fossil, and out of that biomass is 15%.
Okay.
Yeah.
I think Dennis had a question next.
Hi, I'm Dennis. I'm from Kenya. My question is kind of related to Juliana's about how much fuel is in the briquettes from the biomass. Do you said quality also has like a steel production farm, and producing steel requires furnaces which need either coal or some other fossil fuel. Do you plan or do you already utilize the briquettes?
Yes.
It's possible to?
Yes.
Oh, that's nice. How many briquettes, if there's an estimation per maybe ton of steel produced, and about the steel itself, if you utilize the raw materials from like a sustainable source?
Yeah, so out of 1 ton of, let's say, biomass briquette, so you know what you do is you don't put briquettes into the furnace that is making steel, but also there are other processes, like you have to reheat the steel what you have made after a certain process and this and that. You use briquettes over there. Per day I can tell you, like per day it is about 365,000 tons per day biomass briquettes are required by a steel plant which is producing around 1 million tons of steel every year. You get it? So 1,000 tons of biomass is not easy to get, biomass briquettes. So they are not able to meet these targets. Like their requirement is this, but you know, logistics is a big cost in this. So it becomes unfeasible if your biomass pellets are coming from over 100 kilometers. 150 kilometers is your last. Then you gotta be using coal or something else, because then it becomes unviable for you to produce anything from that. So it has to be localized. That much biomass has to be available around the surroundings, and that could be your target.
Why is that 100 to 150 kilometers, that threshold? Why does that exist?
Because of the bulk density of biomass and the volume it occupies. Do you understand that? No.
I do, but just to elaborate.
I'll elaborate, because biomass is lighter than coal. Coal is more dense. Biomass it's light, but it occupies more volume. So any vehicle or anything which is carrying that load will become unviable, because the kind of volume it can carry.
Because the transportation costs are higher.
Transportation costs are higher.
Yeah, under the current economic
Also, one mine of coal can give out millions of tons, thousands of tons every day, lakhs of tons, 100,000 of tons every month. But to collect 1,000 tons of biomass, you have to reach out to 10 different plants around the area to collect. So that's where the logistics becomes unviable. You have to reach out to them, collect all of it, then fill. Rather than going to a coal mine, everything's coming from one side, you fill up the train comes directly to you.
Yeah.
So that supply chain is very different compared to coal versus biomass, because you have to collect it locally from various different sources due to availability of biomass, aggregation of biomass, and processing. So it's not possible to have it on a very large scale at one single location.
It takes a community versus.
You have to
source.
decentralize. You have to have every 5 villages, 6 villages. You have to have one plant, like that.
Next question. Absolutely.
Hi, my name is Jasmine and I'm from Kenya.
Hi.
I noticed that you collect a lot of like plastic waste material, and I've noticed that there's been a concept of like using plastic waste to create like building material, like construction materials such as bricks, in order to use it in more mass quantities. And I was wondering about what you specifically thought about that, because I was talking to an architect and she said that it's a good idea, but then there's the concern of like microplastics potentially harming the health of other people. So what do you personally think about that?
Yeah, so actually from paddy straw, Parali, what I was, from the rice biomass, paddy straw, now there are companies in India who are making plyboards, wooden furniture from the straw. There is technology now, they are compressing it in a way. First they make flat boards, like plyboards we call it. and then you make furniture out of that. So that is also happening. But the acceptability, the viability is, people are still evaluating that. So it's happening on a smaller scale. Yes, there is a possibility. Yeah.
Thank you.
Yeah.
Any other questions? Absolutely, Pedro.
Hello, I'm Pedro
Hi.
from Brazil, and I'm really interested in this because my family works in the field. And so in Brazil we do it with sugar cane, and the sugar cane goes straight to the usine and it gets separated there, and you produce sugar, ethanol, and then you burn the biomass. So with the rice, you divide it in the farm, and then you get the biomass and produce the pellet.
So yeah, when you harvest the rice, you are left with these stems. Yeah. So you cut these stems, and then you shred it. Or you don't need to shred it, like I showed you. You just cut these stems and store it. Before supply to the compressed biogas, you shred these stems. So the rice is taken out. It's gone to the rice mill. Yeah. Then you cut these stems. Is that what?
Yeah, but why do you have to do the pellets, or can you not?
No,
burn
we
it
don't.
straight away?
So pellets are not necessary. We just supply as it is to the compressed biogas plants. They just buy it, shred it, we shred it, and as it is, it goes. But people who have boilers and who are making heat, who want industries which requires heat, they have put boilers. You know, boiler, what they do, they generate heat. So in boilers, then they say, okay, we need rice pellets mixed with mustard, because rice has a very low calorific value. Also, it has more ash, more moisture. So, but just to serve the social cause, they say we want rice mixed, but with a higher calorific value biomass. Let's say mustard, millet, or sawdust.
Yeah. The purpose of the
Yeah.
pellets is they just burn better. And it's
So yeah,
more
you can
centralized.
make pellets from rice, but it has calorific value which is around 2,800, 2,600, which is not. Then you need more and more of that. So boiler people, they don't like it. So they want mixed it with mustard, mixed it with any other biofuel.
Like sugarcane.
Yeah, like sugarcane.
Yeah.
So yeah, sugarcane is best. You can mix sugarcane trash. We call it sugarcane trash, right? Leaf trash. You mix it with paddy straw. It's the best fuel you have.
We have time for one last question. Anybody? No? I have my own then. I was really curious about sort of if we were going to get into this business within our own countries that we come from across the world, what's that first step that they should take?
What's the first step?
To following in sort of this biomass industry footstep
Yeah.
in Poland or in Brazil or in
The
Kenya.
most important part, because since now I'm involved in just gauging and setting up more plants, the most important part I realize, you're talking about pellets, right? Is obviously to analyze biomass availability, but also, as I said, logistics is a major part. So you need to understand that there is industry around it to utilize it. If you put it up, let's say in some part of your country where there's a lot of biomass available, but it's not industrialized, then it becomes unviable. A lot of that is happening around India. So people get excited, they set up plants near where a lot of biomass is available, but then their logistics cost becomes higher. Two things. Actual users, like every industry has a boiler. Textiles, cement, tire, food processing, any industry you say, they have boilers, right? So you need to have an industrial belt around it and find a biomass bank which is within 100 kilometers of those industrial area. This is the formula. Rest all is doable.
Absolutely.
This is natural formula for it to be successful.
Yeah. So if they're coming from an area with a more centralized energy system where the boilers are not within those specific companies, would it be less viable, or they would just need to sell to that more centralized area?
So
In a lot of nations, manufacturing plants of a smaller scale oftentimes won't have a boiler within their own manufacturing plant. They'll just have a high voltage transition system.
you can do that. So you can
still do
supply
that?
to
Still
central.
works?
Absolutely, yeah.
Okay.
I mean, power plants have huge boilers,
Yeah.
and the heat is then goes to turn the turbine. So I mean, your supply, their boiler is about 8 kilometers somewhere, 5 kilometers somewhere, and that's where the boiler is being burned, and then the heat is being supplied to the turbine. So you can do that, absolutely.
Okay.
Yeah.
That's all the time we have. Thank you very, very much, sir,
Wow.
for
Thank
your
you
time
so
and your
much.
presentation.
Thank you so much. No, thank you. Thank you. Thank you.
All right.
Good, amazing. I really enjoyed it.
Thank you all.
Thanks for making it easy.